Alright guys, so this is the second video of section 10.6, and if you haven't watched the first section yet, please go do that one first, but if you have, you're in the right place. Alright, so we have one more theorem and a couple of examples to go over, and then we'll be done with this section. And once again, we are going to be solving quadratics, and this time we can't factor, so we're going to go over the quadratic formula as we did in the past. But anyways, this theorem is the segments of secants and tangents theorem. So basically, it's when you have one secant segment and then you also have one tangent segment. So remember when I said they intersect on the outside to think of double E? Okay, well, the same thing applies here. There's one reason I teach that, and it's because nothing changes here. Okay, so double E, so exterior is EC times the entire ED is going to equal, if we go to here, the exterior is EA times the entire, notice the entire thing is exterior, so the entire is also EA. Okay, or in other words, EA squared equals EC times ED. Okay, so really, if you just remember double E, that applies here as well. All right, so let's do an example. All right, so here's one of my segments. Here's my other. I want to solve for X. So once again, I'm going to do double E, exterior times entire. Okay, so in the green, the exterior is 16 times the entire is also 16. So 16 times 16 equals exterior here is X times the entire thing, which would be X plus 8. All right, so 16 times 16 is just 16 squared, which is 256 equals, then I'm going to distribute this X through X squared plus 8X. Okay, now we have a quadratic. We can't get this X squared to cancel. So first thing I want to do is I want to set it equal to 0. Can't do anything until it's set equal to 0. So I'd get X squared plus 8X minus 256 is equal to 0. Okay, now if I wanted to factor, I'd say two numbers that multiply to A times C, so negative 256, but they add to B, which is 8. Okay, well, newsflash, there are no two nice numbers that do that. Therefore, factoring is not a method here. This is not a way to solve this. So we're going to revert to the only other thing we know, which is great because it can solve anything, and that's the quadratic function, okay, or the quadratic formula. So negative B plus or minus square root of B squared minus 4AC all over 2A is the quadratic formula. All right, so our A is 1, our B is 8, and our C is negative 256. So let's go ahead and start plugging it in. Okay, so negative B would be negative 8 plus or minus square root of B squared, so 8 squared minus 4 times A, which is 1, times C, which is negative 256, all over 2A, or 2 times 1. Okay, now I'm slowly going to simplify this. So negative 8 plus or minus square root of 8 squared is 64. A minus and a minus makes a plus. So 256 times 4 gives us 1024 over 2. Okay, a little more now. Negative 8 plus or minus 64 plus 1024 is 1088 over 2. Okay, now I want to break down 1088. I want to simplify it. So 2 goes into it, obviously it's an even number, 544 times. 2 goes into that, 272 times. 2 goes into that. 136. 268. 234. 217. 17. 1. Okay. Pair them up. So I have 2 times 2 times 2 times square root of 17, so 2. So 8 square root of 17 is 1088. So I'm going to rewrite this, -8 plus or minus 8 square root of 17 over 2. Okay, now notice this and this are all even, so I can divide all those by 2. So -4 plus or minus 4 square root of 17 over 1, or just 1. Okay, now, if I do -4 minus 4 square root of 17, that means that this right here would be a negative number. We can't have a negative length. So, in the context of this, this minus won't work. Okay, so our x here would be -4 plus 4 square root of 17. That would be our answer. All right, I want you to go ahead and do example 4 on your own. Now, this is way easier than the other one. So go ahead and do this one on your own, and then we'll go over it. All right, so you should have gotten 21 as the radius. Okay, so once again, we're going to do exterior times entire because these intersect outside of the circle. Okay, so on this BC here, exterior is 20 and entire is 20, so we just do 20 times 20. And then on the other one, 8 is exterior times the entire thing, so it's just 2r plus 8. That goes right there. Okay, we would have to distribute this 8 through the parentheses, so we'd get 400 equals 16r plus 64, and then it's just algebra from there. So you work it out, you get r is 21.